So the first thing I want to do today is show you how to submit using the 140 submit script. I think it's pretty simple, but can't hurt to have you follow along. So when you're ready to submit your lab, you should first go to your directory that has your particular that has your labs in it. So for example, I might go to BVZ labs and lab 0.5. Okay, so CD, you want to actually be in that lab. So you can see here, if I do an ls, that I have the contents of my lab directory. Okay, and it would be good to have both your executable there and your .cpp file. So this is lab 0.5. Then all you do is you type 140 submit. Please don't do this right now because you're not ready to submit. Only do this when you're ready to submit. It's 140_submit. The first thing it will do is it will show you what your current directory is, and it will ask, is it the correct one? If it's not, just enter no, and then change to the proper directory and rerun the script. Okay, I'm in the right directory, so I hit Y, and now it says, please enter the number of this lab. Okay, so I told you for this one to enter 05, so you would enter this number. And when you do, it will then ask you for your section number. So there's only two sections. You're either in the 8 o'clock or the 10 o'clock. Okay, but the choices are numbered starting at 0, being a good computer science. So actually, if you're in the 10 o'clock, you would put 1. And that's it. It tells you that it's tarred up, it mailed it, and that it's going to receive an auto reply. So at that point, you should wait, and in a few minutes, you should see a automatically generated email message telling you that it has been submitted. So we'll wait in a couple minutes, hopefully it will pop up. So any questions? That's it for the submission procedure. It's a very simple one. If you don't get that email within, say, an hour, you should send some email to Ben and make sure that he actually received it. Okay? The other thing is, I understand that lab was canceled yesterday. It's not changing the due date for lab 0.5. This is just doing stuff that you did in CS 102. So it's meant to be review material. You really didn't need to be in the lab yesterday in order to do it. We were going to go over a debugger called GDB in the lab yesterday. We'll do it next Wednesday instead, along with Topcoder. So, I mean, don't worry about the fact there wasn't lab yesterday. It's no big deal. I had not updated the Topcoder page. It's now updated. We're not going to get to Topcoder until Tuesday, so you don't have to worry about Topcoder until Tuesday. But those dates have been updated and the notes have been updated. Okay, so today we're finishing up CN. We're talking about a few odds and ends like hexadecimal and octal number systems, talking about printf. I assume that you know pretty much how to use vectors and strings. You use them in CS 102. I'm not going to go through and regurgitate what the notes say. If you feel like you need some review, read the notes or read something in the textbook. But we used vectors and strings. Dr. Planck's notes aren't really introducing a whole lot new. I'm going to go over one of the vector programs that he talked about in the notes, the tail one. But for the most part, I expect that you know strings and vectors. Like I say, if you don't, review Dr. Planck's notes. Okay, I'm going to go over some stuff that maybe was more obscure in 102 or that is important for the lab. So with that in mind, we did not cover a whole lot with character input in 102. So if you have a char variable, like say C, you do remember that if you do cin into C, hopefully it will read one character from the input into C. Okay, so let's just write a short program that's going to read some input. So let's get off of here, get into my 140. Let's call it reader.cpp. So I'm going to write a very simple program to declare C and read some input into C. Okay, and then we're just going to C out whatever C is. Okay, so very simple program. Do we agree? We're just reading in some input and echoing it out. We're reading in a character at a time. Agreed? Okay, so let's compile it. And actually, let's create some input. So we have Brad, Nell, Smiley, right? Okay, let's run it on in, and it seems to do what we expect. It prints out Brad, Nell, Smiley. Okay, let's put them all on one line. Add a few spaces. Do it again. Does there seem to be any issue here between what you see in the file and what you see on the output? Is anything missing that was in the input file? Think like Sherlock Holmes did in the case of the dog that didn't bark. Is there anything in the input file that's not in the output? Spaces. Okay, it's ignoring spaces. So the cin command ignores spaces. If you need spaces, you need to use another command, which we're not going to worry about. Okay? It also, let's go back to the original. Okay? So this is the input. You may not realize it, but there's also something missing in this input or output, and it is new line characters. So in the original file, there actually was a control character, \n, which is invisible after Brad, after Nils, but they're invisible because the console treats the control character \n as telling it to put stuff on a new line. So it doesn't actually print it, but if you could see what the string looked like, internally that string actually looks like Brad, Nils, Smiley, with \n's at the end of it, the \n being a control character. So that's actually what the string or the stream looks like. And it's not printing out the \n. Okay, it turns out that this is a nice feature. While this is bad if you're trying to count the number of characters in the file, Dr. Planck's notes go through an example where he tries to count the number of characters in the file, and it's wrong because it hasn't counted spaces and new line characters. But it's super handy for Lab 0.5, where you're prospecting for gold. Because in your lab write-up, you have, let's go to your lab write-up. Okay, you're prospecting for gold. This is dirt. The underscore is empty rocks. This is the 26-ounce piece of gold. This is a 3-ouncer. But what you're doing is you're reading characters one at a time, checking to see if they're between A and Z. If they are, then you have a piece of gold and you print it out. Now, you might think that you have to read things a line at a time because you can get stuff like this on your input. This is a valid input. And you can see the lines don't have to be the same size. So you might be thinking, wow, I need to use getLine for this in order to get a line at a time, and then somehow I have to be able to iterate through that. For example, you could read each one of these as a string, right? You could try to, each of them in effect is a word, so you could try to read each of them. You could say string line, and you could try to say while cin into line. And then, does anyone remember how would you get access to the individual characters on the line? You would have to iterate through the string. Remember from 102 that a string can be treated as though it is an array. And you can get at its size using the size. So you could then say, come on. This pen is breaking and it's only working intermittently. So you could say if line I and compare it to something, and then you could do stuff. But it turns out there's an easier way to do it based on what I just told you, which is that you can do character I/O Okay, that's not going to work, so I'm going to have to try something else. So you can, in fact, do something like this. I'll call the character Earth. And then you can do your comparison involving Earth. And that's actually an easier way to do lab 0.5 because it will ignore any new line characters. So it will just keep reading the thing one character at a time. So even though the file might come in like this, okay, if you remember from CS102, in fact, this is all just one big string. So the file may look like this to your naked eye, but to C++, it just looks like one huge file or one huge stream with one line that looks like this. So that's what that same file looks like to C++. So it just reads it as one big line or stream, reads it one character at a time, and ignores those \n's. Perfect for your lab. Okay? Got that written down since I just gave you a huge hint for your lab. Okay. And remember, when does the lab due? Essentially Friday night. However, for you who are late owls and who don't have Friday night plans, or who do, and who get back to your room at 3 a.m., you still have until 6 a.m. to submit it. But it's essentially due Friday night. And then you have a second lab, just so you know, Lab 1, Checkerboard and Moonglow, that are due in effect next Tuesday night. So don't forget that you still have something to do after that. Okay. Dr. Plank, I think, is hilarious. Some people don't, but I just really love his description of the Moonglow lab, so hopefully you also will enjoy his, what some people might call quirky humor. I'll let you read it on your own time. But essentially, Moonglow is a hippie who is hanging out and unfortunately didn't really botched up the grading for a philosophy course, and you have to clean up after Moonglow. But Moonglow has a big heart, as you see, so. And Moonglow will make, I believe, another appearance in Lab 2. So, at any rate, yes. One of you was laughing. I find it hilarious. Okay. So, moving on. Here we go. A review of Octo and Hex. You should have seen Octo and Hex in CS 130. However, we will do a quick review of it here. This pen is just totally broken. Okay. Well, unfortunately, I'm going to have to use the whiteboard for this. So this part, if you look at it later, won't seem too good on, I'm still taping, but unfortunately, since I can't use that, the camera on my computer won't extend to this board. We'll just have to make do. Okay, so what is Octo? What base? Base 8. Okay, it turns out we don't use Octo a whole lot in this particular course. It is actually the basis for the ASCII character set. So you may remember, hopefully from either 102 or from 130, that the various characters are represented using integer codes. I believe A is something like 60, but I forget off the top of my head if that's true. I think small a starts at something like 95. Can't exactly remember. I think 0 might be 40. I can't remember exactly. But they all have character codes. Okay? And they range from 0 to 127, because originally Ma Bell was using Octo to represent these things. And it helps that they're contiguous, because if you have, say, a D, and you want to know where it is relative to A, you can actually subtract capital A from capital D, and you will get what? Three. So it in fact is permissible. You can declare a char like Earth, and you can actually have an int value equals, say, Earth minus A, and that will give you the integer distance of that character from uppercase A, because the ASCII character set has the nice quality that all capital letters are clustered, all numbers are clustered, all lowercase letters are clustered. Okay. So again, they went from 0 to 127. So that's one of the original uses of Octo. So if you don't remember octal, octal goes 0, 1, 2, 3, 4, 5, 6, 7. And now for 8, it is 10. So this is actually 8 in base 10. 11 is 9 in base 10. 12 is 10 in base 10. Okay? And the way that you get that is 12 in base 8 is equal to 1 times 8 to the first power plus 2 times 8 to the 0 power, which equals to 8 plus, 2, equals 10 in base 10. Okay? So you need to get comfortable with this kind of counting system in different base systems. Okay, now octal, you were actually exposed to another use of octal in lab last Wednesday when you were dealing with change mode. So you remember, what does change mode do?
Sets permissions.
Sets file permissions. And you may remember that a file can have one of 3 permissions, right? There's read permission, there is write permission, and there's execute permission on a file. Read, write, execute. This gives someone the right to read your file, this someone gives the right to write it, and this gives the right to execute it. Now, one form of change mode is using actually the letters. So you could say change mode plus R on foo, and it adds a read permission. But another way that you can use the change mode command is to give the permissions in octal, with 1 meaning you have permission and 0 meaning you don't. So if you wanted to give someone read permission, you would give them a 1, but you didn't want to give them write permission, that would be a 0, and you wanted to give them execute permission, that would be a 1. So you can say change mod. Now you have to know what that number converts to. You can't say change mod 101 foo. That won't work. Okay? You have to instead give the base 5 number for that. Okay, so this is actually in binary. This is in base 2. So this is a 1. So this is actually, in this case, base 2. So it is, this 1 is 1 times 2 to the what? 2 to the second plus 0 times 2 to the what? 1 plus 1 times 2 to the 0, which is equal to 4 plus 0 plus 1 equals 5. Therefore, you actually write change mode 5 foo. But this is really an octal value. It's a 3-digit value, and it can go between 0 and 7. You don't want to give any permissions. They're all zeros, which is 0. And if you want to give all 3 permissions, that's equal to 7. 1, 1, 1. So in fact, octal is the basis for change mode. And if you remember, there's actually 3 sets of permissions, right? There is one for you, one for what's called the group, and one for the world. So you actually provide 3 octal values. So if I said 3, 2, 5, you should be able to, on a test, tell me which permissions I just gave. So, can someone tell me what permissions what permissions did I just give myself? Okay, if you think, I gave myself write and execute. Okay, because 3 is equal to 0 fours 1, 2, and 1, 1. So I gave myself write and execute permission. What did I give group? What's group's permissions? Just write, because 2 is equal to no 4s, 1, 2, and no 0s. And what permissions did I give to world? Read and execute. Okay. So we don't use octal a whole lot, but we do use hexadecimal a ton. Okay, hexadecimal is base 16. Again, hopefully you saw that in 102. I'm sorry, 130. So what is after 9? What is 10? A, then B, C, D, E, and F. So 10, 11, 12, 13, 14, and 15 in base 10. Okay, so if I give you, for example, 3D, you should be able, again, to translate that from into base 10. Okay? That is 3 times 16 to the first, plus D is 13 times 16 to the 0, which is 48, plus 13, so that's really 61 in base 10. Conversely, you should be able to go from base 10, so if I give you 153, you should be able to convert that to hexadecimal. Okay, so we figure out in this case, we have to figure out whether, so the number is clearly greater than 15, right? Okay, so the next up, 16 squared would be what? What is 16 squared? Anyone do that in their heads? 256. So it's less than 256, so it's going to be a 2-digit one. It's going to be something times 16 to the first plus something times 16 to the 0. So we have to figure out how many times 16 goes into 153. Goes in 9 times. How do I know that? Because 160 would be 10. So I know it must be 9. And since 160 is 10, I know that this must be equal to 144. So what's this number got to be? 9. So in fact, I just came up with 99 in hexadecimal. So that's 99 base 16. Okay. If I had made this be just 10 greater, so it was 163, now this would be 10, and this would be 3, so this would be what? A3. Okay, the other thing you need to do is you need to learn how to do addition in hexadecimal. Okay. So if I give you A, B, D plus 3, A, E, you need to be able to do that. Okay. Now, I have to translate just like you would. I know that D is 13 and E is 14, so I know that this first sum is 27. So 27 minus 16 is 11, so I know that 11 is a B, and I need to carry a 1. right? So then B plus A, B is 11, A is 10, so we have 22. 22 minus 16 is 6, so we have a 6 here, and we carry the 1. And finally, 1 plus A is 10 plus 3. It gives us 14, and 14 is E. So that's the sum of ABD and 3AE. If that's confusing to you, it's really just the same. Let's say I asked you to add 384 and 259. 4 plus 9 is 13, right? So what do I subtract? I subtract the base from it, which is 10, which gives me 3 and a carry of 1. Okay, I'm doing the same thing over here, except my base is 16, so I'm subtracting 16 rather than 10. And then doing a carry of 1. Okay? So, did you use hexadecimal for anything in 130? Yes, what did you use it for?
Well, we didn't actually use it per se. We just calculated numbers.
Okay, you calculated numbers.
Sometimes we saw it in assembly code.
Okay. So memory. So generally, the way we represent memory addresses is with hexadecimal, because memory addresses in old machines were 32 bits. In newer processors, they may be 64 bits. Okay, so these are memory addresses, which is pretty, if you try to express it in base 10, can be pretty significant. Certainly, if you try to express it in using bits, it gets to be tedious. But, and I only have 16 bits here, you can express it much more succinctly using hexadecimal, because how many bits are required to represent a base 16 number? 4 bits. Very good. So you can group your memory addresses into groups of 4. And now you go from 32 bits to 8 hex digits. Okay, I know I only have 4 here, but this one would be what? What hexadecimal digit? F. This one would be what's the base 10 number? So 8 plus 0 plus 2 plus 1. 8, 0, 2, 1. So it's B. It's 11. Okay, this one's the same. This one is 5. 4, 0 plus 4 plus 0 plus 1. So you could represent this address, and you normally represent a hexadecimal number as 0x. So when you see 0x in front of a number, it means hexadecimal. So typically, you would see a memory address might look like 5, B, B, F, E, A, C, 4. That would be a memory address, and that's much more succinct than writing out 32 bits. So when you see a core dump, or when you're segfault, or when you're debugging something, typically the way memory addresses get printed out is that way. So you'll need to get used to using hexadecimal in this course. So questions about hexadecimal? Okay. Okay. So next thing that we're going to be doing is a quick review of cout as a prelude to doing something with printf. So in fact, let me just quickly bring up PowerPoint here. Okay, so how do you think about this for a moment? Let's say that you want to print let's say we have double, we're going to use doubles, x, and I say print x in a field that is 6 characters wide and has 2 digits after the decimal place. So how would I do that using cout and IO manipulators? Okay, give that a moment, think about it. So we're talking now about doing formatted output. Okay, can someone tell me how I do it? Yep, there are. Do you remember them though? No. Okay. Okay. So that's one of the problems with using cout, is the commands, they're a little harder to remember. So you have to set the width to be 6. You have to set the precision to be 2. And is that going to work? Shall we see? Okay, but you are correct. That's not, so we'll do that. So we'll # include IO stream. Anyone know the library? IO manip, very good. So let's do int x, double x. We will do cin into x. And now we will say set w6, and we'll set precision to be 2. Let's give it a try. And I'm going to enter okay, so there's, whoops, great. You know, you can always tell me that you can't see what I'm doing. No one ever does seem to tell me that they can't see what I'm doing. Okay, I can because my stuff up here shows it to me. And why are we not? Is this going to take a moment to come up? Okay, just a second. Here it comes. Okay, you could not see me doing this, but this is the program I created. So cout, set w6, set precision to printing out x. I'm reading into x. Okay, so I'm going to enter that number. If everything works properly, what number should print out? What should print out? Todd, I'll pick on you. What do you think is the number that should print out?
Precision was 6 and
The width was 6 and the precision was 2.
23,588.2.
Okay. So how did you come up with that?
Wait, no, never mind. It should be 23,588 because it will display the 6 characters, but the 2 decimal points will get cut off.
Okay.
Because of the 7.
So that's a good try, but in fact, it will print it should print this. Okay? So what happens is it will, if the number is too big to fit in the field, it will be big enough, it will accommodate more characters. It will always accommodate 2 digits for the decimal point, and then whatever is needed. So if it was less than 5, so let's say that instead the number was 41.2389, then in fact it would be blank space, actually it would be blank space 41.24. 1, 2, 3, 4, 5, 6. So the width specifier only comes into play if the number that would be output is smaller than the number of characters. If the number that you would output, which in this case should be this, is bigger, it doesn't truncate, it simply takes as much space as needed. So this is what we should be expecting. Whoops. That's not what we got. We did get 2 digits of precision, 2.4. Exponent plus 0.4. So in 102, you were told how to avoid this pitfall. What's the problem? Yes.
Tell it to be fixed.
Need to tell it to be fixed. By default, it prints out an exponential notation. And if you're printing out an exponential notation or scientific notation, set precision refers to the total number of digits. It's only when you tell it fixed format that it now goes to being 2 digits after the decimal point. So if we recompile it and give it that, it now works properly. Gives us the output we expected. Okay? Now, this is kind of cumbersome. First of all, most of you forgot the commands you needed to use. Okay? I forget them too. They're not all that easy to remember, plus this is a pretty verbose string. So in this course, we're going to be using a new command called printf. And it stands for print formatted output. So I'm just going to give you a quick example here. First of all, I have to include a new library called cstandard.io. But instead of this monstrosity, it's going to look like %6.2f and then the name. So it's much more compact. What this is, the percent says we're starting a format specifier. 6, as you might imagine, says is the width of the minimum width of the field. So when you say set W, that what many of you mistakenly think is that is the maximum width of the field. It's not. It is the minimum width of the field. So it's saying the minimum width of the field is 6. Then the .2 says that there can be up to 2 digits after the decimal point. The F says that we're printing out a floating point number. As soon as you say %6.2, it infers that you want to use fixed format rather than scientific notation. So you don't have to worry about the fixed anymore. So this is a much more succinct way of doing it. And in my way of thinking, it's also a lot easier to remember the formatting command. Okay, so printf Okay, I'm sorry, I know this is clunky. We're going to get that pen replaced, and once we get the pen replaced, it's not going to be this clunky going forward. So printf stands for print formatted output, and it's actually a C command that we will be using in this course because it's simpler. So the general format is printf, a format string in quotes, and then as many variables as you need. Okay, and PowerPoint is capitalizing everything on me, but it really is supposed to be a lowercase p. Okay, so up to variable n. So how does anything that is not preceded with a % sign is literally printed out? So I could say, for example, print fx equals %6.2f, and what will get printed is x equals whatever, 23,588.29. So if something does not follow a % sign, it is literally copied into the output. So here x equal is literally copied into the output. Okay, then a specifier, a format specifier, it starts with the % sign. The first thing after the % sign is justification. By default, what is everything justified? Left or right? Everything by default is right justified. Okay, this is why we're having this review. Don't worry, we know that you forgot a lot from 102. By default, everything is right justified. Not particularly, I'm not sure why, but that's the way it is. If you want left justification, use a dash. So if I wanted the string to be left justified, I would start it with a dash. So if you want it to be right justified, you don't have to put anything in. By default, it will be right justified. The next thing that you specify is the minimum field width, okay, which in this case is 6. The next thing you specify is the number of digits after the decimal point, which you clearly only do for a floating point number. Okay, next is the type of the value. Okay, so there's a number of things. F for, come on. There we go. F if you want float or double. I or D, either one works for an int. C for a char. S for a string, lowercase s. Those are the big ones. Okay, so for example, think about this for a moment. Suppose I want you to print out, so how to do the format specifier to print a string that should be 10 characters wide and left justified. How would you do that? What is it going to be? So if I say printf percent what to print that string in a field that is left justified with a minimum of 10 characters. Dash 10, and then S. That will print it in a field that is 10 characters wide, left justified. Now, one thing that you have to be careful about, let's say I had said name equals. You can't, if I have a declaration string name, and now I say this, I will get an error message. The reason I'll get an error message is because printf doesn't know how to interpret a C++ string. So just as you sometimes had to do in 102, you're going to have to say .c_str, and that will extract a C-style string that can be printed out. That's only with string variables. Okay? I strongly urge you to learn how to use printf. It is many times easier to remember and a lot more succinct for creating formatted output than cout. For this course, we will continue to use cin, but we will use printf to produce formatted output. Okay, so in the notes, there are some, so here's just an example where we simply print hello world and we're not printing the values of any variables. So remember, the format string does not have to print variables, it just might be printing text. You're not limited to just printing one variable. So here is a string that is printing I is %d. So what is the type of I? What is %d? An integer. Is %d, that's my second variable being printed. And here's my third variable. So I'm printing three variables, and here are the three values that I'm printing, I, j, and I times 2. And that produces the output you see here. So questions about printf? Okay. The I/O manipulators don't work with printf. So with printf, you will be using \n all the time now. There is no endl. If you want a new line, you will have to use \n from now on. Okay? I just find this so much easier than using cout. Like if I want to say, for example, I want to print out name equals xxx. No, let's say I want to print out first name, like Vanderzanden, comma Brad. If I want to do that with cout, I have to do something like cout. I have to say last name. Then I have to remember to put a comma and a space. Then I have to remember to put first name, then an endl. Whereas with printf, I can just say %s, comma, space, %s backslash, last name dot c_string, first name. .c underscore string. And I know in this case it's longer, but I still think that it's a prettier thing and an easier thing to look at. You may disagree, but I think it's easier. It's certainly, I think, easier to remember. So if your question is, do I have to learn printf? Yes, you must. You're not allowed to use cout. So starting with, I would say, lab 1. I'll let you still use cout for lab 0.5 because some of you may have already submitted. But starting with lab 1, you should be using printf. Okay. So, as I said, if you don't remember vectors very well or strings, read the notes. I am just going to quickly go through an example with the tail function. So if you remember, a vector is like an array, but it can store an arbitrary number of elements, and you use the pushback command in order to add elements to a vector. So I have a program that I want to write called tail, which is going to print out the last n lines of a file. So if it's a Unix command, so let's take a look at okay, so let's take a look at insort. That's cat actually. Insort index.html. So if we cat index.html, we get that mess. Okay, here are the last 5 lines of it. So tail is meant to print the last 5 lines of a file. Looks like clear. Okay, it printed the last 5 lines of the file. So we want to write a program that is going to print the last 10 lines of the file. So we're going to hard code the fact that it prints the last 10 lines. Well, if we want to do that, we're going to have to store the entire program into a vector. Okay, we could do an array, but what we're going to do is we're going to have a vector, and we're just going to start accumulating lines in the vector. So entry 0 will have line 0, entry 1 will have line 1, entry 2 will have line 2. Let's say that it's a 500 line file, so entry 499 would have the last line. So if we wanted to print out the last 10 lines of the file, which 10 entries should we print? From what to 499? 490 to 499, right? Okay, so here's Dr. Planck's program. He declares a vector of strings. Then he uses getLine to read lines one at a time from cin, and he reads them into the variable s, and then he uses the pushback command to add the line to the vector. Now he sets his starting value to be the size of the vector minus 10. So in this case, the size of the vector is 500. He's subtracting 10. That gets him his starting point I. Okay? Now, this is where you can't make an assumption that the file is longer than 10 lines. Let's say that the file was only 5 lines long. So it stopped there. What's the problem with this calculation? I is going to end up as what? What will i's value be in this case? What's the size of the vector? 5 minus 10 equals minus 5. Okay, what happens if we start trying to print at minus 5? Well, let's give it a whirl and I'll show you what happens. So, let's do this. By the way, you'll find out that foo is my favorite, for whatever reason, thing to do. Yeah. Int. Okay, so I'm only going to enter 5 lines. 1, 2, 3, 4, 5. Oh, that's right, it worked because we didn't have this. Let's take that out. Okay, 1, 2, 3, 4, 5. That shouldn't be working. Line 1, line 2, line 3, line 4, line 5. There we go. What happened? Nothing. In fact, we got lucky because we were actually referencing entries. Let's see. We were actually going for, when we printed them out, we printed out lines minus 5, lines minus 4, lines minus 3, lines minus 2, and lines minus 1, and we were very lucky that the program didn't core dump because we were outside of the array, and oftentimes when you're outside of an array, you core dump. We call it a core dump. There's an abortion. It aborts due to some error. Yep, segfault. Okay, it didn't segfault in this case, but often it would. So, to fix that problem, you add the line that you see there in blue, which is if I is less than 0, you set it equal to 0. Okay, and then since you've already set I, there's no reason to change the value of I, so that's why that's empty there. Then, while I is less than the size of the array, you print out the align. I'm sorry, less than the size of the vector, you print it out. So questions about that? We good? Yes, Gavin.
You don't have to include that first piece in the for loop. You can just leave it blank and it'll...
Yes. The question was, can you leave this first part of the for loop blank? And the answer is yes. So in that case, it's just saying nothing should be done for initialization. You actually, I believe, could leave this middle one empty, in which case it would default to true. And you can actually leave the last thing empty as well, in which case you have to do the update inside the loop. So, not usually a good idea. Usually the only thing that you see empty is this first part. Okay, now, Dr. Planck also noted that this is incredibly inefficient for large files. It has 5 million lines. We're going to end up storing 5 million lines in memory. But how many lines do we need to print out? 10. So this is a situation where if we use a little thought, we really, if we're clever, only need to use a vector that is 10 elements big. You might think, how can I do that? Well, here's the idea. Once you fill up the array, or the vector rather, sorry, I keep calling it a. So once I get down here to line 9, and now I read in line 10, what line do I no longer need? What line can't be printed out once I read line 10? Line 0. So the idea is that we will now put line 10, we will replace line 0 with line 10. Now I read line 11. What line that is now in here can no longer be printed because it's not part of the last 10 lines in the file? Line 1. Line 1 will no longer be printed, right? Okay, we have line, think about it, line 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just read line 11. What are the last 10 lines in the file? Where does which lines are we going to print? 2 through 11. So line 1, when we read line 11, line 1 is knocked out. Okay? Think of it like I'm a race car fan, and they only qualify a certain number of cars for every NASCAR event. So let's pretend it's 39. So they take the 39 fastest ones and they keep qualifying ones. When someone qualifies faster than the current top 39, number 39 gets bumped. Same thing here. Line 1 just got bumped, so we replace it with line 11. When we read line 12, what line can no longer be printed? Line 2, so we replace line 2 with line 12. So what we're doing is every time, once we've filled the vector, we know that every new line we read replaces an old line in the vector. So we simply replace the old line with the new line. So we just kind of roll over. Do you see what's happening? Okay, this is a common trick. So that's what he's doing here. He's counting lines with ln. Now he's saying if the line count is less than 10, we do the pushback. Otherwise, the vector is full and we need to replace a line. Okay, well, the line we replace, notice how line 12, if you mod it with 10, it replaces 2. Line 13 is next. It should go into location 3. So he's just using the mod operator to determine which line he's replacing. And then he replaces the old line, which is this line, with this new string and increments n. And then when he's done, he sets I to be ln minus 10. Again, adjusts I if necessary. And now when he's printing out, he does I mod 10 because his starting point is not necessarily the end of the array. Let's say that we stopped after line 12. So let's say at line 12, that was the end of the line. So in that case, ln would end at 12. I would be set to 2. Right? So I would go up to 2, and eventually I would become equal to 10. When we get to 10, we should roll around to the top of the array, which is what the mod operator does. Mod, when it gets to 10, rolls us around to the top of the vector, where we end up printing lines 10, 11, and 12. I believe he actually, sorry, he sets I to 3. I get set to 3 initially. Okay, and actually LN ended the day at 13. It didn't end the day at 12. It ended at 13. So questions about this little roll around trick. Get used to it. This is a very common trick that is done in programming. If this trick using the mod operator is not looking right to you, I suggest that you get a scrap of paper out and work on it sometime between now and next Tuesday. Work it out in your head, make sure you understand it. I will go through this evilness that he has here at the beginning of lecture next time, and then we'll go on into top coder and command line arguments.